Hi, this is Reese with Research, and in this video, you will learn how to use your kinematic equations to answer motion on an inclined plane questions. Now, in previous kinematic equation videos, I had shown you motion on a flat surface. But what about motion on a surface with an angle? Well, that's motion on an inclined plane. And for motion on an inclined plane questions, you can use the four main kinematic equations that you've used for other kinematic problems. But what changes is the value you will use for acceleration. So when you're answering motion on an inclined plane question, and the only force acting on the object is gravity, then you will use the acceleration value, A is equal to plus or minus g sine theta. Now it's important to note, I said the only force acting on the object has to be gravity. Well, what does that mean? Well, imagine we have a ball, and that ball is rolling down a hill. And if we forget about friction, then the only force acting on that ball is gravity. Gravity is pushing the ball down the hill. So for that ball, we could say the acceleration is equal to plus or minus g sine theta. Here's another example. What about a skier gliding down a mountain, and then they hit a jump and glide off of it? Well, in both cases, the only force acting on the object is gravity. So the acceleration would be plus or minus g sine theta. Here's an example where that wouldn't apply. Imagine we have a car with an engine. That engine is applying a force that is pushing the car up the hill. So we would not use the A is equal to plus or minus g sine theta acceleration because the engine is applying its own acceleration. So what we just learned is that when you're answering motion on an inclined plane questions, and the only force acting on the object is gravity, then the acceleration value that you will use is A is equal to plus or minus g sine theta. And let's break this down. G is the acceleration due to gravity. It is always equal to 9.8 meters per second squared. Theta is the angle of the incline. Whether it be 10 degrees, 20 degrees, 45 degrees, it's the angle of that inclined plane. Now, what about the sign of acceleration? Is it positive or is it negative? Well, it depends on the situation. Let's look at this example. We have a skier. They're going down a mountain and then they launch off of a jump. We know that this is motion on an inclined plane, and we know we can use the A is equal to plus or minus g sine theta acceleration value. But what is the sign? Let's look at the down the mountain part. We know an object going down an inclined plane speeds up. And so let's look at our velocity vectors and our acceleration vector, because for an object that is speeding up, the velocity vector and acceleration vector have to be in the same direction. In this case, the velocity vector is to the right, and the acceleration vector has to be in the same direction, so it's also to the right, and that means the acceleration is positive. Now let's look at when the skier was gliding up the jump. Well, we know that an object that is going up an inclined plane is slowing down. And when you have an object that is slowing down, the velocity vector and acceleration vector are in opposite directions. So we know the velocity vector is still to the right, but the object is slowing down. So the acceleration vector has to be to the left, and that means the acceleration is negative. So what does this mean? Well, it means that when you're determining the sign of your acceleration, you have to look at the situation and you have to ask yourself, 1. What is the direction of the object's velocity vector? 2. Is the object speeding up or is it slowing down? The answer to those questions will help you determine the sign of your acceleration. So now we know when you're answering kinematic problems with motion on an inclined plane and the only force acting on the object is gravity, you can use the A is equal to plus or minus g sine theta equation. One last note before we go. Don't be afraid in these motion on an inclined plane questions if you have to use a little bit of trigonometry. And that's because these inclined planes can form right-angled triangles. And what that means is you might have to use trigonometry to find the angle of the incline, or to find the displacement of the object. So what I've done is I've made two motion on an inclined plane problems to help you practice. They require you to use your kinematic equations, to know that the acceleration is a is equal to plus or minus g sine theta, and to use trigonometry. So try those questions to test your knowledge. And with that, that's the end of our video, which showed you how to use your kinematic equations to answer motion on an inclined plane questions.